Next up, we have Daniel Kahn from Dynatrace, who is going to show us how the open source project Open Telemetry is really driving the innovation around observability and distributed tracing. Take it away.
Okay, hi, almost. So we will come to the topic in a second. Thank you for joining me from wherever you are. We have a lot of ground to cover, so I will start right away sharing my screen, and you should see it now. So my talk is called Observability, Distributed Tracing, and Open Source, the missing primer. And I will show you a little bit the range of the topics that we will cover. I'm tuning in from Austria. We are best known for Mozart, Red Bull, and Californian governors. Yes, I'm Daniel Kahn here. You have my contact info. Feel free to screenshot it. I'm Director of Technology Strategy at Dynatrace. We are a monitoring vendor. We are the market leader in the space. And there I'm responsible for a lot of things, but also for everything open source and open source monitoring and all standards attached to it, and also our contributions to it. And besides that, I'm also one of the chairs of W3C Trace Context, also a topic that we will cover during this talk. So why am I doing this talk? In my role, I get a lot of words thrown at me constantly at different occasions. And I'm asked, do you do that? Do you do that? Do you do distributed tracing? What about observability? And I found that there is a lot of confusion in this space. And because there is a lot going on, so that's not a bad thing. But clearly, there is some need to do something that kind of covers the whole story end to end and not just pick one topic and describe that. And I want to take you on a little bit of a journey through all those like topics and technologies and like give you a little bit like of a framework also, by some example that I have here. So my story starts with the monoliths, like many stories start. And I, of course, have to show something from Kubrick's masterpiece here. Every time I have to talk, I'm talking about a monolith. So things were pretty easy back then. And honestly, at the programming or platform conference, likely I would not have been able to place this talk at all because developers were used to kind of throw their stuff over the fence because they and operations folks then took care of the whole monitoring topic and collecting stuff from the application and see how good it is running. Because on the developer side, they were fine because they could use the ID, some debuggers to attach to it, to profile it. So they knew basically what's going on. But things changed in the meantime. So suddenly we have still some presentation layer, but now we also have an API gateway. So this is the thing the presentation layer uses to connect to the services below that you see in blue here. So now we have a lot of services. And to make things worse or better, whatever, we also have a lot of different infrastructure providers, which also have their own services that they provide. And now it gets complicated because all that is running over the wire. So suddenly you're not calling in process, one function calls the other. Now you're using gRPC, HTTP, whatever, to call those services. So things, of course, get more complicated with that. So as a developer, I'm now developing, let's say, my cart service, and I can run my unit tests there, and that's fine. So I know it's not completely broken, but I kind of don't know how it's behaving now in the whole application that is now microservice architecture. So what I will do is I will have some pipeline, and I will push my my service into pre-production and later push it further into production. Then I, of course, want to know how well my service is doing. And suddenly I want to look at things like latency, response time, error rates, or even the number of queries that are executed in this service. So I have now KPIs I want to watch. And you might already figured, so I'm talking about metrics here. Metrics contain time correlated data points. And there are a few typically metrics type, like a counter that's like and monotonously increasing value. Think an odometer in your car, hopefully it never decreases, it should always go up. up. Then we have gauges. Gauges are increasing and decreasing values. So that's your tachometer in the car. And then we have histograms. These are groups of values that are kind of grouped into buckets. Let's say your engine connects the knock events between 0 and 50 miles per hour, 51 and 100 miles per hour, and so on. You get the drill. And of course, somehow I collect these metrics now in my application. And then there are always ways to chart these metrics. And of course, it depends on largely also on the type of metric, how you would chart it then. And additionally, you will, of course, use this charting to maybe also define some thresholds, so values that you know that are wrong, and then you want to be alerted, most likely. A typical pipeline for collecting and charting metrics, and there are a lot of ways to do it. And I'll show you just something I see pretty often. It's like you have your Spring application, and then there are plenty of libraries that can collect metrics or can help you report metrics from your application. So there is Open Telemetry, Prometheus, everyone knows that, Micrometer or StatsD. Then you have to get out of process with those metrics. And very common, but that's of course not the only way to do it. We have Telegraph. So Telegraph is cool because it can take metrics on the left side and use plugins to transform it to some other format and put it out there on the right side. And in my case, I'm using now InfluxDB. That's so Telegraph and InfluxDB, both open source by Influx Data. InfluxDB is a very solid open source database and for time series. And the next thing I want to do, I want to, of course, chart the whole thing. And for that, I'm, in this case, using Grafana, which is the open source tool of choice for charting, to be honest. And such a chart dashboard would then look like that in Grafana. That said, all vendors, like commercial vendors, also provide integration for that. Just to give you a quick glimpse, so like Dynatrace also has an endpoint that will that understands StatsD protocol, or there is a plugin for Telegraph that can also directly push to Dynatrace. And this is true for all commercial vendors as well. Fine. But now you're coming to your office in the morning and you look at the dashboard and you see that there is some error rate, 242, but some requests are still succeeding on your card service. So your boss is now like that, wants to know what's going on, and you're like, I have no idea, because you just know that something is wrong, because the complexity has moved to the network layer now. And you just don't know where to look at, because the service, when we look at, there is the client, there's the API gateway, we have some service, then we have more services, and there is a card service, which is again calling other services. So you just don't know where this error is really coming from. And to make matters worse, not all requests are actually failing. So what will you do? So your question, the question that you have is, which requests lead to an error in your card service? And an obvious way to now think about it and what you want to ask actually is now, so I need to have some concept of a transaction. I want to know when a customer clicks this button, check out. I want to know or add to cart. I want to know which call this was that actually fails. And this leads you automatically to some way of transactional thinking, and such transactions these days are called traces. So how can you collect the trace? Now you need some way to identify one request of a customer end to end. And you will likely come to the conclusion that you have to pass along some kind of an ID. And I use A42B here. And likely you use some header and just pass along this ID now tier to tier. And this ID is called the trace context. So that's a typically trace context ID. That said, a trace is also a tree of spans, because spans represent a single operation and contain metadata like the HTTP method, or also a database query or some error code. So if we look at the trace again, we will also have spans below that. So these are now single operations that are running in your tiers. So usually they're also represented in a Gantt chart. And then maybe you have a database. And also there you see that we don't only have process to like spans that spawn different tiers. We also have in-process spans. So this means when one application at your API calls the database, it will also kind of create spans. We still don't know how to create the spans. So just saying, that's how it works. Now let's look at how this trace context can even be propagated, because I now said so easily, okay, gets propagated through the tiers, but of course this is way not so trivial. So you get a request into your card service and it hits your HTTP handler. Let's say it's HTTP. And now you have to extract this value. And then you have to propagate it in process. And that can be sometimes simple, like in Java, maybe you use a thread local storage. But sometimes in Node.js, where everything is asynchronous and running in a single thread, this is kind of a science, how to keep this trace state context persistent through while this request traverses through this one tier through your card service. Then in the end, when the outbound request takes place, you again have to inject this header, and then you have the outbound request, and the game starts with the next service. Of course, you won't do that all by yourself. So there are libraries that do that, and you can say do auto instrumentation. And examples for that are Zipkin, Sluice on the Spring Boot world, Open Telemetry, and commercial vendors do this as well. So now, how does such a header look like, such a trace context ID? Basically, each vendor and each system basically had their own proprietary way to propagate this context. So there were various ways to do that. There's the B3 header by Zipkin, and there is also W3C Trace Context. And this is something I want to talk about in more detail. W3C Trace Context, the goal is for that to define, W3C is a standard body, you hopefully know that, and the goal is to define a standard that makes sure that all monitoring systems and middlewares agree on one format for trace context propagation. Because the idea is, if you have something monitored by Open Telemetry, something is AWS owned, some Zipkin stuff and some Open Telemetry again, that you have still an end-to-end trace, because each system in between knows how to manipulate and propagate this header. And then, of course, the outcome would be such a header. So this is the perfect world when there is one standard for that. I'll show you real quick how this trace context looks like. So you have two header fields, that's the trace parents and the trace state. And they have some identifiers. Most importantly, there is the trace ID that is unique for the whole trace. And there is the parent ID, which defines is the ID for the parent span, so the calling span. And with that, you can basically build out your tree of spans. And then there is also the trace state, and the trace state is a list of stuff vendors put in. It also is kind of the history of which kind of systems participated and by which vendors participated on this given trace. So if you have AWS, then there would maybe be one entry for AWS with some specific stuff for them. And then there would be maybe Dynatrace as also one entry. And then there would be Open Telemetry as other entry. So that's W3C Trace Context. You can read it up. This standard is online, and it's already finalized. Now, so far we just talked about how to instrument the code and how to propagate context, but we have not that data collected yet. So nothing is happening. So what we need is some kind of monitoring system, whatever it is. This monitoring system will now collect this data, and for that, usually agents are installed. This means someone installs an agent in the application, it runs inside the application, and this agent usually does the auto instrumentation, collects different kind of metrics and trace information, and then reports that to the monitoring system. And from that, the monitoring system can again create this tree of spans. So of course you need some storage layer for that. There are a few data collection presentation systems where you have Zipkin, and they have basically different capabilities. While Zipkin and Sluice have agents and also instrument and do the storage part and the presentation part, Jaeger is very common for displaying the data. So it does only also persisting the data. Sorry. So it does only the storage and the presentation part. So that's important. And that also creates some confusion sometimes, because if you look at OpenTelemetry does agents and does instrumentation, but no storage or presentation, but it can export again to Jaeger or to Zipkin. So those things kind of intersect in different ways. Of course, again, commercial vendors usually cover the whole stuff from agents to presentation. This is how Zipkin would look like. Likely you know it. So this is now your Gantt chart with the spans and the operations that are on there. And this is Jaeger. And you see it's pretty similar from how it looks like and what it provides. Also, of course, there are commercial vendors that do that. That is a screen in Dynatrace. And also you can, of course, derive a lot of stuff from that. If you add an entity model to that, then you can also look into how services are really talking to each other and collect more information from that. So now let's assume we are looking here, we are looking at Zipkin and we see something red. So now, or we saw the error rate increasing before on a cut service. So now I look at the traces and I filter by errors. And then I see already, okay, I see there are traces. These are the traces that are actually failing. So now I can go into, again, look at my service stuff and I look into the traces and then I see, okay, the client stuff, everything works, the service runs, and then the card fails. But also there, actually, the real thing that really fails is not the card itself, but the currency service that is maybe beyond, so that is called by the card service. And then you can look at the metadata that is reported in such a span, and then you see, okay, someone sends with the GET request the currency, and it's euro. And maybe the real currency code would be EUR, so not the whole word. And that kind of makes the currency service now, makes it to fail. That's now the explanation why it does not always happen. And so the problem is basically solved. So you used for, and we can look at that. So we used metrics to learn about a problem. We used distributed tracing to pass along a unique ID. And we used the monitoring system and its agents to collect the traces. And in the end, we looked at the metadata of such a transaction to identify how it differs from succeeding ones. Now, I've mentioned OpenTelemetry a few times, and this is so important that I dedicate a little section to it. So OpenTelemetry was created in early 2019 by a merge of OpenCensus, which did something very similar, and OpenTracing. So they decided to merge together and be OpenTelemetry. And OpenTelemetry can now report metrics, traces, and also logs. OpenTelemetry consists of APIs, SDKs, exporters, and collectors. This means it does not have some persistence. It does not have some UI where you can look at. It's just a plain like software library, and it's available for different kinds of technologies or languages. And other vendors or like other systems can integrate, they can plug in their own SDK, but they can also create their own exporter. They can plug an exporter into the collector component that can collect traces and data and telemetry data from different sources. So there are various ways to integrate this OpenTelemetry. I show you just real quick how to instrument the node application. You see there, in the first 3, 4, 5 lines, you see that we are instantiating, requiring OpenTelemetry, and then we set up the tracer and we set up the exporter. And then further down, we see that we are now in line 23 do this start span. So this creates now a span. So that's a manual instrumentation of this request. And what we're looking now is the server component. So that is the handle request function. It will create a span when an incoming request is handled. For the client, we just have to require OpenTelemetry, and it will auto-instrument this HTTP GET call automatically. This is what I told you, so that auto-instrumentation will take care of putting the header on there and everything. And if you look then into Jaeger, you see that the client calls the server, and you have the spans there, so as expected. OpenTelemetry is really important for developers. Because it helps them to debug their stuff during development and locally, and that's really something that is really something that is needed, and that's also the reason why we see so much.
All right, looks like we're having some technical difficulties, so hold on and we will be right back.
I'll cue you back in again. All right, you'll be on in 1 second. Go ahead and say a word for me.
Hey, yes.
Hey, we're back and live.
Okay, thank you. So I hear my echo. So there was a glitch, but that's usually when you do Zoom calls. So what I talked about was OpenTelemetry is great for all developer use cases. And we see that a lot that people are instrumenting their stuff, doing development to manually create spans and to trace their stuff. Because as I said to you, there is no way to debug everything locally now. And the usual backend is Jaeger for that. In production, I have to say that usually all commercial vendors put a lot of stuff on top of those things. So we have topology, behavior, code level visibility, metadata. And you also have to maintain, of course, some backend. You have maybe some manual instrumentation that is also taken away from you usually. And you also have no support model and no enterprise features. Still, vendors care for OpenTelemetry, and Dynatrace is also one of the main contributors there, because there are so many technologies, and right now we have to reverse engineer each and every library. So that is something we can look at, because we are now low on time because of the glitch. This is all, of course, costly and time-consuming to reverse engineer all libraries. So the idea is to get something like OpenTelemetry hooks into your library. So if a library is developed, it includes OpenTelemetry, and then And as you see here, there would be then just from different vendors, wrappers that just tap into those library instrumentations. So OpenTelemetry is bound to become some kind of standard. And as Sergey Kantsev of Google says, we want every platform and library to be pre-instrumented with OpenTelemetry, and we are committed to making this as easy as possible. So OpenTelemetry is first of all a tool for developers, but also something that will be a standard, and likely all vendors will slowly abide to supporting OpenTelemetry the one or the other way. Real quick, I want to talk about observability. Observability is something many talk, so there is a lot of thought about that. But basically, observability just means that you could have to collect data in such a granularity that it can answer you unknown questions, so-called unknown unknowns. So you see, with pure monitoring, you know that your response time is higher than 50%. But with observability, you can answer questions like the response time of the checkout increases exponentially with the number of items in the basket because of a misplaced for loop, and that executes the same database query times number of items for every item in the basket. This means this lets you drill into the data, and for that, so to be a system to be observable, you need a lot of very granular data, and a highly observable application provides that to you. Let's put this all together. Metrics can help you to learn about the problem. Distributed tracing becomes increasingly important to understand multi-tier execution paths. Developers now really rely on metrics and traces. Pure open source solutions are viable for pre-prod environments. Standardization is the only way to tackle today's complexity, and open source is the key driver. And vendors are prepared to tap into that data collected by open source standard tools to add enterprise features on top to support web scale workloads. And with that, we are still almost in time. Thank you. And yeah, let's see you in the Q&A session. So I will chime in there in a second.
Thanks, Daniel. Great recovery from our technical glitch. When it comes to debugging issues in Kubernetes, I know I get lost really easily. So it's great to see OpenTelemetry coming in and filling in that gap and giving us that thing that's capable of visualizing and interpreting that complex distributed system so that we can more easily debug them. We'll be right back in a few moments.